Hola amigos, this is Nerdinair and you are watching Nerdinair Tech. Today we will take a look at basic electronic components.
So guys, let's take a look at the diodes. I will show you first some samples. This is a single phase bridge rectifier, 35 ampere 1000 volts. This is a 3-phase rectifier. This is the positive, negative, and these are the 1, 2, 3 phase. This is a 3-phase bridge rectifier. This is also a 3-phase rectifier. As you can see, the diagram is shown here. And this is a single phase. The center two are the AC, and this is the negative, and this is the positive.
This is also a diode.
This is 16 ampere 120, that is 1200 volt. And here the direction is shown. This is the anode, this is the cathode. And this is a 3-phase rectifier. This is the positive, negative, RST. The diagram is shown here.
नीचे जाते हुए पूरी ताकत से विनोद कर ही दो.
This is a 3 ampere diode, 19540. See the silver lining? This denotes the cathode, anode cathode. And this is a 1 ampere diode. The previous one was 3 ampere, BA159, ultra high speed switching diode. This is a zener. See the black lining? That is the cathode. The diac.
Now let's see the diagram.
Normal diodes A, zener, diac, SCR, triac, see this is SCR. These are the gates. This is the terminal. The diagram is shown here. How does the diode work? So the diodes work in the forward direction only. So the current flows from here to here. The circuit is complete. Now when the diode won't work, in the reverse condition the diode won't work. So let's see. This is the same diagram. Now the current won't flow because the diode conducts in only the forward direction. But the zener has to be connected like this, reverse direction. I will show you a diagram for the rectifier. Single phase. So now we will take a look at the LEDs and lights. This is a 7-segment display. These are the big ones, 3 inches. This is the small type. These are the lamps used in stroboscopes. These are old school lights. This is a 3 mm LED and this is a 5 mm LED. LEDs come in various sizes: 3 mm, 5 mm, 7 mm, 10 mm, etc. High power LED, white LED used in torches, etc. This base is the heatsink, and these are indicators used in textile industries. There is a supply point in this, and this is the center one point. Normally when the thread is going, it is held up. When the thread breaks, it drops and contact happens and the light blinks. What is LED? LEDs are diodes only.
This is a diagram of a LED. Now we will take a look at the Ics and Optocouplers.
This is one of the optocoupler, PC923L. See the dot and this cut straight line. This is the input side and this is the output side. This is the other type of opto. See the notch here. So this is the input, this is the output. This is a small SMD opto. This is another opto. See the dot. That is the input. So, what is an optocoupler? The opto consists of a photodiode and a phototransistor. This is the basic function. These are used for safety because these are optically isolated, no electrical parts and no noise. Because it is optically isolated, so there will be no noise in the other side. These are used for switching applications. So let's take a look at the fuses. This is a HRC fuse, 55 ampere, 690 volt AC. This is also a HRC fuse. This is a glass fuse, 35 amperes. Fuse holder. These are the contacts. You put the fuse inside and tight it. This is also a fuse holder. You can easily connect these wires to the circuit, then you are ready to go. Just turn it like this and put the fuse inside. This is also a fuse, 15 ampere to 50 volt, small shape.
The diagram of a fuse.
Let me show you some samples of the IGBT. This is a single IGBT with a diode for brake applications. This is a IGBT module with inbuilt rectifier. This is a IGBT module without rectifier. This is a IGBT module without rectifier. These are the UVW, DC, positive, negative, gates. This is a 50 ampere IGBT. This is a MOSFET, gate, drain, source. This is a transistor. This is a metal transistor, 2N3055. You would have seen this in many amplifiers. This is a CL100 metal transistor for relay switching applications.
This is a SCR. Now I will show you the diagrams.
This is the NPN. This is the PNP. And this is a Darlington pair. How the transistors work, let me show you. This is the NPN. This will be the base, a collector, emitter, same like that. P, N, P, emitter, collector, base. So in the PNP we would have to give a negative current for the switching, and in the NPN we have to give a positive current of the base. Then it conducts, makes a path, and the collector emitter continues. Insulated gate bipolar transistor, that's IGBT. In this the gate is isolated. The base is called the gate and the collector emitter, that is same. The MOSFET also has a gate, drain and source in place of base collector emitter. MOSFET, metal oxide semiconductor field effect transistor. So the transistor FET, the BJT is the NPN, PNP, MOSFET and JFET. Transistors are current controlled and MOSFETs are voltage controlled. These are MOVs, metal oxide varistor. We put it in the parallel to the supply line. For example, if a single phase in the phase and neutral and three phase drives face to face. What this do is, when there is a voltage rated more than rated, it shorts and blows the fuse input, so protects the circuit. CTs. Let's take a look at CTs. CTs are current transformers or current transducers. What is the difference with transformer and transducer? This is a current transformer, CT. This only has a coil with the core, ferrite core. This is the positive and the negative output. The wire goes in between. Current transducer. This has a circuit. This also has a coil here and some ICs and other integrated in the side, integrated inside. This is the setting presets. This is a LEM 50 ampere. So now let me show you some relays. This is a relay with the base, relay base. This is the lock system and we pull it out. See, this is the coil point and these are the contacts. This is the 4CO, 4 changeover. What does 4CO mean? 4CO means 4 changeovers, 4 NO-NC contacts. This is the common NO and this is the NC. These two are the coils. Common NO-NC, common NO-NC, common NO-NC, common NO-NC. 4 contacts. This is another type of relay. This is simply an electromagnet. When we give supply to the coil energizes and pulls this metal towards itself, and this pushes the fin forward and the contact breaks from the NC to the NO. This is a cube relay. Function is same, just it is in a cube shape. In this, these two, this one and this one are the coil. This is the common NC NO, and this is a 24 volt relay. And these are another power relays, 30 ampere, 12 volt. These two are the coil. This is the contact, common NO, common NO. And this type of relays are found in PLCs. These come in 12 volt, 5 volt, 24 volt, etc. So now let's take a look at the transformers. This is a 15015 1 ampere AC transformer. Transformer is nothing but an inductor. The principle is called mutual inductance. The SMPS transformer. This is fully enclosed transformer. This is a special type of epoxy that can transfer heat. This is a pulse transformer. This is an inductor, ferrite core inductor. We also get air core inductors, but this has a ferrite core. These are heat sinks. These are made from aluminum for transferring heat of electrical devices. mostly used for MOSFET, SCR, IGBT, rectifier, etc. The MOSFET heatsink.
So guys, that's all for today. See you in my next video. Take care guys. Jai Hind, Vande Mataram.